Acids. Acids are chemical compounds that share similar properties. All acids have a sour taste. Lemons and other citrus fruits, for example, contain citric acid, and vinegar owes its sourness to acetic acid. Acids also cause color changes in plant dyes. For example, they will turn blue litmus paper red. Litmus is a substance extracted from lichens and is commonly used to determine whether a solution is acidic, basic, or neutral. Many acids will react with metals and cause them to dissolve, while others react with organic compounds containing carbon. Hydrochloric acid, for example, is produced in the human stomach and aids in digestion by dissolving ingested foods. Yet another property of acids is that they will react with bases to form salts and water. Chemists define acids in several ways. In the 19th century, the Swedish chemist Svante Arrhenius stated that an acid was a substance which produces hydrogen ions when dissolved in water. Hydrogen ions are positively charged hydrogen atoms. Under normal circumstances, hydrogen atoms contain one proton, which has a positive charge, and one electron, which has a negative charge. But when a hydrogen atom loses its electron, it becomes a hydrogen ion. The problem with Arrhenius's definition, however, is that it applies only to acids formed when water is the solvent. In 1923, chemists Bronsted and Lowry independently formulated a theory defining acids as substances capable of donating a proton. When hydrochloric gas is dissolved in water, for example, it acts like an acid by giving protons to the molecules of water to produce hydronium ions. It is true that the Bronsted-Lowry theory of acids is the most widely used, but some chemists today prefer an even broader definition, which states that all acids can be defined as electron pair acceptors. This means that an acid will readily accept electrons from other atoms or molecules. When this happens, the acid and the donor molecule form a new molecule by sharing the electron pair. This definition includes Bronsted-Lowry acids as well as acids that do not contain hydrogen atoms and thus cannot be proton donors. Chemists commonly categorize acids based on their strength, which is determined by the extent to which the acid ionizes in a solution. When hydrogen chloride gas, for example, is dissolved in water to form hydrochloric acid, its molecules break up into hydrogen and chloride ions. Because every molecule of hydrogen chloride gas readily separates into ions, hydrochloric acid is considered a strong acid. Acetic acid, on the other hand, forms only a few ions in solution and is therefore considered a weak acid. Acidic solutions containing a stronger acid will have a higher concentration of ions than solutions containing weaker acids. The scale used by chemists to measure the degree of acidity of a solution is called the pH scale, the values of which range from 0 to 14. A solution with a pH value of 0 is extremely acidic, while a solution with a pH value of 14 is extremely basic. A neutral solution, such as pure water, is neither acidic nor basic and has a pH of 7. Common solutions exhibit a wide range of acidity. Milk, for example, has a pH of 6.5, meaning that it is only slightly acidic, while digestive juices found in the stomach are highly acidic, with pH values between 1.0 and 2.0. Acids may be further classified as organic or inorganic. Organic acids are compounds that contain carbon atoms, such as ascorbic acid or vitamin C, and acetylsalicylic acid, commonly known as aspirin. Amino acids, which contain nitrogen, are also considered organic acids. They are the building blocks of proteins and are an essential component of life on Earth. Other acids, such as sulfuric acid and nitric acid, are inorganic acids, which generally do not contain carbon atoms and are commonly used in the manufacturing of such industrial substances as metals, paints, plastics, and gasoline. Sulfuric acid is used as a fluid in car batteries, while nitric acid is mostly used in fertilizers and explosives. Despite the fact that the majority of known acids are synthetically produced for industrial purposes, many others occur in the natural world and have proven necessary in a wide variety of life processes.